There's one of them off.
They're all on.
They're dim. That's all that I can do. Okay. So the distance formula, D equals RT, distance equals rate times time. You've been using that one for a while. So on these types of problems, you're going to be given two of your variables. You need to find the third. So you're going to start by writing down your formula. So we have distance D equals my rate is. Now when you do this, I want to see the substitution. I want to see the units written like so. 15 miles per hour times 3 hours. If you want to put that over 1 to help you keep track of the fact that that's the way the fraction works, that's not a bad idea. Now the reason I did that is because I have an hour in the bottom, an hour in the top. They cancel. What are my units on my answer?
Miles.
Miles. What's 15 times 3?
45.
So I get 45 miles. Now, once you've done the unit analysis that way, now you look back and you say, does 45 miles of distance make sense? Yes, it does. So the units analysis can help you make sure that you're doing things in the right order. You check to make sure they make sense. Okay, so let's look at the second one over here. This time, we have time is 2.5 hours. Distance is 200 miles, and I need to find the rate. So I'm going to start again by writing down the formula every time. Distance is 200 miles. Rate, I don't know yet, so that's R. Time is 2.5 hours. How am I going to find the rate?
You divide by 2.5.
Divide by 2.5.
Which is 80.
Okay, so you're going to divide by 2.5 hours on both sides. Now, looking at the equation, what are my units in my answer going to be? Miles per hour, and it shows right up there in your equation. So I get R equals 80 miles per hour. Okay. Any questions on those? Okay. Let's look at a different formula. This is one you should know. We used it all the time last year. Perimeter of a rectangle. Anybody remember that one?
Yep.
Perimeter equals. It's going to involve an L and a W.
L times W.
That's area.
2A plus 2B.
2A plus 2B. They gave me L's and W's, so I'm using it. Okay, perimeter equals 2 times the length plus 2 times the width. For a rectangle, well, this is my L, and this is my W. P is your perimeter. Okay, I'm given my perimeter, my length, and my width, so I have written down my formula. I'm going to use that one. I'm going to substitute, and I want you to show the substitution. 2 times 30 inches plus 2 times W that I don't know. Okay, what do I need to do? Actually, I'm gonna do a little shortcut. 2 times 30 is 60. So if that's the case, what do I need to do next in order to find out what W is? Subtract 60 inches. And I need to divide by 2. Now you'll notice when I subtracted the inches, it just stays inches. If I were to multiply the inches, what would I have? Inches squared, and that's when you get area. Okay? So then I get W equals 70
Inches.
inches. Don't forget to label it.
Captain.
Questions on those? Pretty straightforward, but I want to see all the work. Okay?
That's it?
Nope. Oh, heavens, no. Okay, we're going to have some story problems. And here's this one. We have a wall that's 62 feet long. I have 4 banners. Each one is 8 feet. I want to space them evenly on the wall. So first thing you're going to do, you're under control there. You're going to draw a picture. There's my wall, 62 feet. I got 1, 2, 3, 4 banners. Each of those is 8 feet. Now, it's an equal distance from the banner to the wall and between the banners, so I can use the same variable for all of them. What variable you want to use?
X.
Okay. X it is. Now, when I have a story problem, I've drawn my picture. What do I need to do next? Oops, I gotta get an X in there. Let X equal. How am I gonna define my X?
Space between there.
Space between banners. And we're going to measure that. The feet's always a good idea to know what your measurement units are. Okay. Any ideas? Raise your hand if you can give me the equation you would write to represent this.
5x minus 16. Wait, 5x plus 4 times 8 feet equals 16 feet.
Go ahead. Okay? So, I want to see that equation, and I want to see it like this. I don't want you to multiply first. I want to see it like this so it represents what the picture looks like, okay? So that's the first step. Now we're going to solve it. 5x plus 32 feet. So we're going to subtract 32 feet from both sides. And we get 5x equals 30 feet. Divide by 5. And x equals 6 feet.
Done.
Okay, questions on that one? There'll be a few story problems. So this is the last slide. Okay. Another thing that they're going to give you is some tables that look like this. Let's make a story to go with this one. The top one is time in seconds. The second one is height. You are at 2,000 feet, probably in an airplane. And you drop something out of the airplane. After 1 second, it's at 1,750 feet. 2 seconds, it's at 1,500 feet. 3 seconds, it's 1,250. What's going to be at 4 seconds? What is it?
1,000.
1,000. How did you figure that out? Minus 250 each time. So this was minus 250. That was minus 250. Minus 250. Minus 250. Okay. Now, if I let time be t and height be h, I want to write an equation to represent that table. Okay? So I'm going to say h equals
T times 250 minus 2000.
close. Close. It's going to be, when t is 0, it's going to be 2,000. You just have your signs mixed up. Otherwise, okay? And then every time t goes up, I subtract 250. So I say minus the 250 times t. Everybody see where I got that? Okay, when t, and then if you're not sure, check it. When t is 0, this is 0, so h is 2,000. When t is 1, this is 250, so this is 2,000 minus 250, and so on. If you're not sure, check it. You know what? If you want to sleep, you can go do it with Miss Teal. Just be writing them down. Okay, second type of problem, or this is the same type of problem, let's just do x's and y's this time. Okay, look at that. Raise your hand if you can tell me the equation you would write to represent it. You got my last one, Doug. I'm going to give somebody else. Okay,
equals
Brian, did you raise your hand? Okay.
y equals x never mind. I know how to get done
Okay,
before.
when x is 0, what's what? 11. So that's going to be your first number.
11
Now, what changes
add 4.
plus 4 each time?
So 11 plus 4x.
4x.
Yeah.
What's going to go in the blank over there?
27.
27. Okay, so those aren't too hard. When they're like that, when the change is the same every time, we call that a linear equation. And if you graph it, it looks like a line. Okay? And that should be reviewed from last week too. Oh, this